So here's the Bonetti machine. The Bonetti machine is an electrostatic generator that's somewhat related to the Wimshurst machine, except that it doesn't have sectors, metallic sectors around the edge of the rotating discs. But apart from that, they're pretty similar. So the key function, or the key requirement, is to have two counter-rotating discs of an insulating material. So in this case, we have a geared arrangement on the motor so that one of the discs at the front will rotate counterclockwise and the one behind will rotate clockwise. So there's an arrangement where there's a belt drive at the back of the motor which transfers to the front, and then there's a gear drive that will reverse one of the independent hubs. The other key parts of the machine are the collectors. So this is where the charge is collected. So the charge, say positive or negative charge, is collected at this one, and then across the machine, horizontally opposed, collects the opposite polarity. So in this case, we got red for positive. Other parts are the neutralizing bars. So unlike most machines, I've made this one where both neutralizing bars project or are attached to the back of the machine. But there's two independent bars. They connect the front of the machine diametrically opposite. And then the rear of the machine also connects diametrically opposite. There's no contact with the disc. It's all done by high intensity field that ionizes the air. So there's no contact, but air is ionized because of the sharp points and allows charge to be transferred. The neutralizer bars are fairly close to 0 volts in between the plus and the minus voltage of the main pickup. So the insulation on those is not particularly critical. But you'll see that with the actual charge collection bars, I've had to coat them in tool handle rubber coating. It just stops some of the corona discharge. Any sharp points on the high voltage section is going to lose a lot of efficiency. So that's why I've got big round bowls where there's any sort of charge concentration. Now this machine is set up kind of experimentally. It's not complete and it's not optimum. So I've had to do a few little tricks to get it to work properly. Anyway, so the charge that's collected from the disc is fed into a capacitor. So the capacitor in this case is made out of a big ABS plastic sheet that's a dielectric between two sheets of foil. So there's one capacitor on one side, the other capacitor on the other side. It's fairly all balanced compared to ground. You can't see it, but the foil extends out to these electrodes where the spark gap can be set. So I can rotate these handles to adjust the width of the spark gap. So you see in operation, this machine will develop about 100 kilovolts, so which is a spark length of about 100 millimeters. So I'm taking the standard dielectric breakdown of air, which is about 1 kilovolt per millimeter. So it's a pretty hefty spark, and the capacitors that I've set up here on the plastic sheet, that totals about 500 picofarads from one electrode to the other. So at 100 kilovolts, this is going to discharge 2.5 joules per spark, if I can get it to 100 millimeters in length. So the machine's now running. You can hear it's pretty noisy. You won't be able to see all the sparks from the phone because the shutter speed won't always be synchronized with it. But we've got a fairly short spark gap there. So I can start increasing it. So that's about the practical limit. So I'll stop the machine now and we'll measure that gap. Well, that gap turns out to be about 90 millimeters. I need to fiddle around with it a little bit to optimize it. Let's give it another try. That's more like it. It likes to discharge from a fairly small radius to a larger radius. That's mainly because of the inefficiency of the machine I've got here. There's a lot of leakage. As you can hear it, if you can hear that hissing sound, that just means you're wasting your power. Okay, so that gap was about 110 millimeters or so that's a pretty good voltage. By the way, the power supply I'm using for this is just a 24 volt supply. I'm just using this bottom one. The other power supplies aren't in use. It's also going through a resistor, 3.4 ohms or so, just to cut down the current so that the motor doesn't get like a big burst of current when you start it up. The motor will be using about 40 watts or so, and by the rate of the discharge of the spark, it's about maybe 1 or 2 watts. So the efficiency is not that great, but it's not too bad for an electrostatic generator. When I was developing this machine, I had a bad idea, and that was to use my lab power supply to run the motor. Well, it was convenient, but it also blew up the lab supply because this motor needs to be grounded. If it's not grounded, it picks up a static charge. Eventually it arcs over back into the power supply. And a lab power supply is a little bit delicate on the output because of the current limiting. So it's best to use a chunky old power supply like the switch mode power supply instead.